Welcome to The Explainer. Okay, if you're thinking about using a sperm or egg donor to build your family, you know you're facing a ton of big decisions. Today, we're going to cut right through all the noise and focus on what is maybe the most crucial decision of all, making sure your donor is genetically compatible.
You know, it's so easy to get caught up scrolling through donor profiles, looking for someone with a great smile or an impressive college degree. And look, those things matter to you, for sure. But today, we're zeroing in on the one factor that isn't a preference. It's a medical necessity for your future child's health, and that's genetics.
So to help you get a handle on this, we've broken it all down into 5 key parts. We'll start with why this is such a critical health decision. Then we'll get into the number 1 single most important genetic rule you need to follow. After that, we'll look at some other red flags to watch out for, talk about the best tools to find them, and then wrap it all up with a simple checklist so you can make your choice with real confidence.
All right, let's dive in with the big picture. Why does this matter so much? Well, because when it comes to genetics, choosing a donor isn't just about finding a good match. It's really about fulfilling a medical responsibility to give your future child the healthiest possible start in life. And right at the heart of that responsibility is one single, non-negotiable rule. Seriously, if you remember nothing else from this explainer, make it this. This is the absolute foundation for making a safe genetic choice. So the rule itself, it's actually super straightforward. It's all about avoiding one specific genetic overlap. We're going to get into what a recessive gene mutation is in just a second, but the main idea is this. If an intended parent is a carrier for something, you have to make sure your donor is not.
Think about it like this. When 2 partners have a child together, they're working with the genetics they've got, right? But when you choose a donor, you have this unique and incredible power. You can actually screen for and completely eliminate this specific risk before you even start. That's a level of prevention that is just, well, it's truly remarkable. Okay, so let's break down that term, recessive gene mutation. What does it actually mean? Just think of it like a hidden instruction in your DNA. It only causes a health problem if a child gets 2 copies of that exact same hidden instruction, one from each biological parent. If you only have 1 copy, you're called a carrier, and you're almost always perfectly healthy, probably with no clue you even carry it.
And this slide right here shows you exactly why that rule is so critical. See on the left? That's the safe scenario. You've got a parent who's a carrier matched with a donor who is not. No problem. But on the right, that's the danger zone. Both are carriers for the same thing, and that is a genetic lottery you never, ever want to play. So what are the odds in that lottery? A 1 in 4 chance. For every single pregnancy, there's a 25% risk that the child will be born with that genetic disorder. Now, that is a huge risk for conditions that can be incredibly serious. And this is the key. It's a risk that is 100% preventable just by following the rule. Okay, so once you've made sure your donor doesn't share any of those recessive mutations with the parent, you've already cleared the biggest hurdle, by far. But for even more peace of mind, there are a couple other genetic red flags you should probably know about. We're going to look at 2 main areas here. First up is a group of conditions called X-linked disorders. These affect males and females differently. And second, there's a pretty small number of recessive genes that are worth taking a closer look at, even if they don't create that high-risk match we just talked about. Let's talk about X-linked disorders. These conditions are tied to the X chromosome. Now, most sperm banks will screen their male donors for these, but an egg donor can be a perfectly healthy carrier. The thing is, if she passes that gene to a son, there's a 50% chance he'll have the disorder. And because that risk is so high, it's generally a good idea to avoid egg donors who are carriers for serious X-linked conditions. All right, the second red flag, this one is a little more nuanced. Remember how we said most carriers are perfectly healthy? And that's true. But for a handful of conditions, being a carrier can sometimes come with some very mild health effects. So it's just something to be aware of when you're looking at a donor's profile. Here are some good examples. You can see that a carrier for sickle cell trait might have some issues at high altitudes, or someone who carries the gene for hemochromatosis could have slightly high iron levels. Now, these are not necessarily deal breakers, especially if the donor is a fantastic match otherwise. But this is exactly the kind of thing you'd want to go over with a genetic counselor, just so you understand all the potential implications. Okay, so we've talked about what to look for and what to avoid, but how do you get all this information in the first place? Well, luckily for us, modern medicine has an incredibly powerful tool that makes this all possible.
Today's gold standard is something called expanded carrier screening, or just ECS for short. And this is not some basic test. We're talking about screening for hundreds of different genetic conditions all at once, including a lot of diseases that are rare but really serious. And to really get how powerful this is, just look at how far the technology has come. I mean, a decade ago, a comprehensive test might have looked for maybe a few dozen conditions. Today, we are talking about panels that screen for over 400 different issues. The level of insight you can get now is just on a whole other level.
Now, when you cast a net that wide, it's actually really likely that a donor, and frankly, most of us, will be found to be a carrier for something. And you know what? That is perfectly okay. Being a carrier is normal. The goal here isn't to find a donor with a perfect genetic report. The goal is to use all this detailed info to avoid that one specific high-risk match.
So this all leads to a really simple but really effective strategy. Let's say you're trying to decide between two donors and both are genetically compatible with you. Well, you should lean toward the one who's had the most comprehensive screening. More data is always better. And if everything else is equal, the one with fewer identified mutations is just the lower risk choice.
Okay, we have covered a ton of ground. We've talked about the one absolute rule, the other red flags to look out for, and the amazing technology that gives us all this data. So now, let's pull it all together into a simple, step-by-step checklist that you can use to evaluate any donor you're considering.
Here's your game plan. Step 1. Never, this is the hard stop, never, ever choose a donor who shares a recessive mutation with the parent. Step 2. Avoid. When you can, steer clear of donors with X-linked disorders. Step 3. Be cautious. That just means take a second look and ask questions about those higher impact recessive genes. And finally, step 4, select. Always prioritize donors who've had the most thorough screening. That's your path to a truly confident decision. And honestly, this might be the most important takeaway of all. You do not have to do this alone. You're not expected to become a genetics expert overnight. A genetic counselor is an absolutely essential partner in this whole process. They're the experts who can take these complicated reports, translate them, answer your questions, and really guide you to the safest, most informed choice for your family. Choosing a donor, it's an incredible act of hope and planning for the future. And by putting genetics right at the center of that decision, you're not just picking a donor. You're actively building a foundation of health for your child. The whole point isn't to be anxious about genetics, it's to be empowered by them. And now, you have the framework to do exactly that.